Hello everyone, welcome to our pre-calculus pre-recording video. This is graphs of rational functions part 2. That means this is the continuation from our last lesson where we started the graphing rational function. So we'll connect previous lesson and this lesson so that things make sense. So in this lesson we will of course we'll try to look into some detail about the graph so that we can draw a complete graph. But of course, all the concepts of previous lessons is necessary here. That's for sure. So first item is testing lines for intersections. Let's say we have these two lines. Where they intersect? How do we know that? Okay, that is the question. Actually, we have the answer. If two lines intersects, then they will be somewhat, let's say two line intersect, kind of that here. That is the intersection. Say one line here, one line here. This is the intersection. And in fact, if you solve these two equations, if you solve this, you will get the point of intersection. So how do you solve it? You make this equation equal to this equation first. Twice x plus 4 equals to minus x minus 5. How can we do that? Because this is y equals to, this is also y equals to. So y and y is same thing. If they intersect, then they will be same. Then at the point of intersection, of course, then we have twice x plus x. X comes from this side to this side. Then minus 5 minus 4. 4 goes to this side. So we get thrice x equals to minus 9. So x equals to minus 3. We divide both sides by that. So it looks like at x equals to minus 3, this 1, 2, 3 here, at x equals to minus 3. But this is not the point of intersection. We will have to put it here to find out the y value. So 2 into minus 3 plus 4. So we get minus 6. So we get minus 2. Minus 6 plus 4 means minus 2. So the point of intersection is x equals to minus 3, y equals to minus 2. So that means this point. This is the point where x equals to minus 3, y equals to minus 2. So it looks like these two lines should intersect at this point. Okay, two lines, one line coming this way, that way, then they will meet at that point. Okay, so this is what the line of intersection means, and this is also the solution of these two lines. This is the solution. This is the two lines. This is the solution. Minus 3 comma minus 2 is the solution of this two lines. Solution actually means where they will meet. Okay, where the two lines will meet. So let's look, and you can exactly see at that point two lines are intersecting. That is what is called solution. That is what is how we understand if two lines will be intersecting or not. But I think you will you notice that basically this is, you can say, sir, these concepts are related to level 100 topics because the straight line, drawing a straight line, and so basically this is very easy. Why you are discussing it? We have a reason. We have a reason why we are discussing it, because that concepts we can bring it here. This is more try to find out point of intersections, or if they will intersect or not. Answer is yes. You can check your calculation if that comes or not. So sometimes they can intersect at the somewhere in the middle also. Of course they align, that's why they can do that. And what about this one? Try to find out if they intersect or not. Let me do it with you all. So 3x plus 2 equals to thrice x minus 4. So you bring thrice x from this side to this side, so what you get? Thrice x minus 3. And also you do not have to bring it actually. From both sides you have the like terms. So you can cancel them out. Then this is 2 equals to minus 4. And what is happening here? 2 equals to minus 4. That means this is the end of mathematics. In mathematics, 2 equals to minus 4, this is completely absurd. I mean, this is not possible in uh, in any case. If it happens, that means we are inventing new maths, and we should not do that. This is too early to do that. Uh, so, so, so if you see this kind of situation arises where you get something like this: 2 equal to minus 4, 1 equal to minus 1, 1 equal to 5. That means this is a wrong conclusion. That means these two lines will not intersect. In fact, they are parallel lines. In fact, they are parallel lines. That's why they will never intersect. If you draw it, then you will see that, oh my god, they are parallel lines. Also, if you look at the function, you will notice that they are parallel lines because their slope is same. So that means their inclination is same, and they have different y-intercepts. So like this and this, they have different y-intercept, but the same slope. That means they are parallel lines. So no solution means what? No solution means this kind of conclusion you will get, like false conclusion. But solution means you will get some real conclusion, some true conclusion. That means at that point you have intersection. If you have some solution, if you do not have any solution, if you have some false conclusion, that means you do not have a solution. All right. Now, why we have introduced it is we want to test it in our rational function. Notice that we said our graph of rational function, we said that the graph of rational function sometimes intersect our horizontal asymptote or oblique asymptote. Sometimes. Now, how do we know if they intersect or not, or where they will intersect? How we will know? We can, let's say, suppose you have a horizontal asymptote here, now sometimes the graph, what the graph does is, like, graph goes and all of a sudden it goes through it, then it goes some up, then it starts coming back to the asymptote, because in the asymptote it will start coming back. Suppose we have more a clear example here. So at this point they at least intersected. So how can we find it out? What can we do is, we will write this equation of this horizontal asymptote or oblique asymptote, and the actual function, we will write actual function one side equal to the horizontal and oblique asymptote. Okay, actual function here, the function that we are solving, and equal to the horizontal or oblique asymptote, and then we will try to solve it. If we get some value, true answer, that means they will intersect at that point. And if we get some false conclusion, that means they will not intersect anywhere. So let's see. So we have oblique asymptote because the power is one more in the numerator. So if we divide it, of course, then we can get the asymptote. This is x squared plus 1 divided by x. So asymptote is this. Now, see what we have done here. What we have done here is, we have written our question. This is the question. We have written just the original question equals to the asymptote, and then we tried to solve it, and we found, is it a correct conclusion? 1 equal to minus 1. This is not a correct conclusion. This is a false conclusion. That means this, in this oblique asymptote, the function will not intersect, because it is a false conclusion. Now what about this one? Here you will have a horizontal or oblique. The power is same. So we will have a horizontal asymptote here in this case. We will have a horizontal asymptote in this case. So does that horizontal asymptote intersect with our graph of the function? How can we find out? First you find out the horizontal asymptote, then equate it like this, then find out x equal to something whether you get or not. Try to do it. We can this is for the practice. Okay, try to find it, and you will get something interesting there. Like you may get some solution or you may not get. So give a try and find it. Now let's review all the things that you have learned how to draw the rational function graph. First of all, from the rational function, we can find out the domain. From where we find out the domain? We find out from the denominator domain. Plot x-intercept if x equals to 0. So we can find out the x-intercept by putting x equals to 0, then we will get the y-intercept always. Because y-intercept, at every y-intercept, x equals to 0, that is the reason. So number 1. Number 2, write the function in the lowest terms and cancel the factors, because here we want to find out any x-intercepts, the zeros of the numerator, determine the function's behavior near x-intercepts, so we can find out that as well. Or one alternative is, for this one alternative is trying some points. So x-intercept will come from where? X-intercept will come from the numerator. Vertical asymptote will come from the denominator. So domain and vertical asymptote will come from here. But remember, domain will come from the original function. Vertical asymptote will come from the reduced function. After the cancellation, these two numbers says, after the cancel, when we cancel out the common factors, then we will find out the vertical asymptote. Find the horizontal and oblique asymptote. So we will compare the degrees of this highest power of x in the numerator and the denominator. So by comparing it, we can find out the horizontal or oblique asymptote. Case 1. If the degree down here is more, then always horizontal asymptote is y equal to 0, regardless of what you see here or whatever the number is. If degree is down more, doesn't matter, 1 more, 2 more, it doesn't matter. If degree downside is more, like say x square divided by x cube, or x to the power 4, or x to the power 5, doesn't matter. Here whatever the number you see, doesn't matter, always y equal to 0 if the degree is more here, down here. This is case 1. And case 2 is if the degree is same, suppose x square then 2x square, degree is same, and then more other things here, then asymptote will be this number ratio of this number. So 1 by 2, y equals to 1 by 2 will be the asymptote of this number. Just a second. All right, I'm back. So yeah, I was talking about the degree. So if the degree is same, this is case 2, then horizontal asymptote will be here y equals to 1 by 2. Degree is same. And if the degree is different and one more in the up, like x cube divided by not me, someone else. So degree is, let's say, 1 more in the up, x cube or something like this. So see, degree is 2 here, here it is 3. 1 more in the up. That means it will have some oblique asymptote. And oblique asymptote y will be y equal to something plus something small, something like ax plus b or something like that, or ax plus b, that format. How can I find out? We can just do the long division here, then we'll get it. Okay. And if the power here is, the gap is here 1, but if the gap is more than 1, let's say this is 5 and this is x squared plus 1. So on huge gap. That means there will be no oblique or horizontal asymptote here. So this way we can find out oblique or horizontal asymptote, this four number. And of course, but the vertical asymptote part we will have to calculate separately. That's not dependent on horizontal asymptote. Horizontal and oblique asymptote are dependent on each other, but not the vertical. Vertical is independent. I mean, vertical asymptote first we will have to find out without considering like long division, power, etc., etc. After doing the simplification, like cancelling the common terms, and first we find out the vertical asymptote, then horizontal asymptote, then it works better. Then find the value of the function for some points. Of course, these 4, 3, these numbers actually they are coming from our previous lesson. This is the part 5 number is we are including here in this lesson. Find the values of the function for some points on each side of the zeros of the numerator and zeros of the denominator. So when we have some zeros, then actually we can plot some of the points, and in the, let's say you have a vertical asymptote, then you know that there is a point here. We will show you the example. You have some point in the left side or right side, then we will just try to find little more points just to find out through which direction the graph will grow. Find few more points. Determine the function's behavior near each asymptote. That helps because then actually we can find out the direction of the graph where it can go. So combine. We will have to combine it. We will show you the application now. Like how do we apply all these things? Let's say this graph, this function. So fx equals to x square. We will try to draw the graph of this function. Fx equals to x square minus x minus 6, x cube minus 3x square. So what is the domain? First of all, we can find out the domain without considering anything. Just directly from this denominator, we can find out the domain. So x cube minus 3x square. Then domain will be what? Domain will come from this denominator. Actually, x equals to 0. X cannot be 0 and x cannot be equals to plus 3. That too is the domain. X cannot be 0, x cannot be plus 3. Then to find out the vertical asymptote, we will have to cancel out, as you know. So we cancel out this, we get this. So the vertical asymptote will be x equals to 0. And to find out like if there is any y-intercept, we put this x equals to 0, 0, then you get actually fx equals to plus y equals to 2. That is, that actually in this case, no, this is 0, 0, then actually it becomes undefined, but that means there is no y-intercept. And actually that is true because we will have the vertical asymptote at x equals to 0. That means the graph will never ever go to that y, it will never ever cross the y line, because x equals to 0 is the y line. And x-intercept, to find out the x-intercept, what we do is we look at the numerator, this thing. So for what value of x it becomes 0? If x equals to minus 2, because it is plus 2 here. If x equals to minus 2, then it becomes 0. That means x equals to minus 2 is our x-intercept. So y-intercept not possible. Vertical asymptote. These are these. So far we got all this information. We got the information that from here we know that x equals to minus 2 is our x-intercept. We know from here that our vertical asymptote is x equals to 0. X equals to 0 is our this line, this dotted line. X equals to 0 is our line. So far we have obtained this information. Now compare the horizontal and oblique asymptote and their intersections. To do it, we will have to compare the up and down, and we know that we can do it easily. And here the downside is power more. That means it is y equals to 0 will be the asymptote. See it, y equal to 0 will be the asymptote. So this is the asymptote because power is more in the downside. That is the reason. Does the graph touch or cross? So we can just write y equal to 0 here and try to find out if it is touching or crossing anywhere, and it does actually. It does actually, because see, if we write x plus 2 divided by x squared, and another, our asymptote was, this is fx equals to and our asymptote is y equal to 0. So if we write this equals to 0, because we are equating now, then you see x plus 2 equals to 0, then x equals to minus 2. That means at x equals to minus 2, our graph will pass through this point, to this asymptote, through this point. Graph will pass through this point, which is actually on the asymptote. So it will actually go through the asymptote, horizontal asymptote. This is how we can calculate that. Okay. So now now check for some other points. This is the part that actually is, in addition to finding this and that, all the concepts, all the knowledge we apply, then still we will have to think about some points, because so that we understand it through which direction the graph will go and exactly what point it will go through. Okay. So let's say this is our 3, so you put 3 in the function, like f of 3 equals to minus 1 by 9 it comes, so minus 1 by 9 is somewhat here, then some points like this is for minus 1, we put minus 1 in the function, then we get this value which is plus 1. Let me show you this calculation, at least one of them. All of them are same. Let's say minus 3 if we put, so you see this is x plus 2 divided by x squared, so if we put minus 3, we get minus 3 plus 2 divided by minus 3 whole square. So this equals to minus 3 whole square means 9. Minus 3 plus 2 means minus 1. So that means minus 1 by 9, which is written here. If you put minus 1, it becomes minus 1 plus 2 divided by minus 1 whole square. So this equals to, you get what? You get minus 1 plus 2, that means plus 1, and divided by 1. So this equals to 1. That's why this point is for at minus 1, this is plus 1. So minus 1 comma plus 1. So these are the additional points that we are taking, because we need to draw a correct graph that follows exactly the path where the graph should go. This is the addition. Now you can say, sir, how do I know where I should find these additional points? You will know it by looking at this line. Consider some of the points to the left of this vertical asymptote, to the right of this vertical asymptote. That is the technique. Okay, horizontal asymptote, not that important, but when you have intersection, then we will have to think about, okay, where it will go through. Let's find out a couple of points, because it has intersection. Okay, then you will have to find out a couple of points for the horizontal asymptote, like left of that point, of this point, left of this point, and right of this point. 1-2 point is enough. Suppose one point you have found, this is good enough, because now we know that the graph will go towards this direction. It will, of course, it will go up like that, and one point you have found here, so that means the graph will go like this, then it will come closer to that asymptote, because we know that the graph comes closer to the asymptote. Okay, yeah, this is so this is possible, and some more points in this side, in the right side of the asymptote, vertical asymptote. So choose some points like to the left of the asymptote and to the right of the asymptote, vertical one. That is the main technique. And only if you have the intersection, then some of the points for that intersection also. Okay. Not everywhere you will not have to find. We will not have to find everywhere. That is too much task. So when you put this value 1, then actually we get 3. If we put 1 here, so 1 plus 2 equals to 3. 1 square means 1. 3 divided by 1 means 3. So we get that. Now see a very tempting, very tempting wrong graph. Suppose up until here, some people draws. Let's say you have found these points and you're like, oh my god, I got the answer, I'm so happy. Then you draw the graph like this. because you see all 3 points are on the on somewhat same direction. So you draw the line, you're like, oh, I got the graph. I thought I don't understand, but actually I got the graph. And then you will not get marks in the exam, and you'll be like, why it happens with me? Why? Actually, you violated the law. This is the vertical asymptote. The graph cannot go through that. The graph cannot go through that. You just got 1 point, and it doesn't mean that it will intersect with the other points, because that's another side of the vertical asymptote. So what should we do? We can find few more points this side. Not too much actually, like 1-2 points. Then actually we will get the shape of the graph. But don't make a conclusion. Like if you get a 2 points, 3 points, like oh my god, they are matching, I will draw the line. No, we'll have to continue with the all the rules. Like okay, rule number 1 this, rule 2, rule 3, or rule for the vertical asymptote, rule for the horizontal asymptote. At least these 2-3 things, these are the main things. At least these main things if you follow, then they will help. Okay, or else it is tempting. See, it is tempting. It looks like, oh my god, it looks like correct. Okay, so few more points. This is actually 3. At 3 it will be a whole because we cancel out that terms. That is why it will be a whole. At 3 you can put it here just to find out where it will go. Like you can put plus 3 here. So 3 plus 2 divided by 3 square. 3 plus 2 means 5. 5 divided by 9 is square. That will come some decimal point that you can put here. This is a whole, by the way, because we cancelled out that term. Remember, we cancel out x minus 3 from up and down. So at that point we get a whole. We said that this is not in the domain. We said that domain is x is not equals to 3. That is why this is a whole. You will see, notice that graph will go through this. So combining all of them, now we can draw. Actually, if you draw it by computer draws it like this, and actually our graph is also correct. And if you draw it roughly freehand, then the graph should like something, let's say, or we can do it another way also. Let's say we come from something like this. Then we will not go through this, we will just then continue from here. And as much as possible, the line has to be curved. The line should not all of a sudden change the direction. Like maybe this line is better. It will go there, and then it will be a curve. Then this side it will be like this. Yeah, so that side it should not. Stay away from this forbidden line. This is the wall. Our car should not hit the wall. And then arrow sign both sides. This is also important thing, arrow sign both sides. Okay, so this will be our drawing if you want to draw. Now you can say, sir, this point, this is tricky. This point, we already know this point. So maybe the graph should go this way. Answer is no. The graph will again come close to that horizontal asymptote, because in which direction we said that they are Romeo and Juliet, they will come closer. I mean, even if they cross somewhere, like they at some point they go, someone goes London, someone goes Switzerland, then again they will come back. Okay, they were just trying to go somewhere else, but no, they will again come back to come closer to each other because they are asymptote. So this is the drawing. One important thing here is whole. Always mention the whole, or else it will be a mistake. This and that, and then the whole drawing is this. Entire drawing is this. As you can see it here. This is the computerized drawing. So this is done here. Actually, this is interesting. Computer do not show the whole here, right? But yeah, it should show. It should show. Let's see. Let's check. Why the computer is not showing the hole here? Maybe Desmos cannot show, but it should show actually. Also, in the meantime, you will see how to find out how to draw the graphs only, not how to check your graph. This is how you can check desmos.com. You can go there and then you just write the given function there. So the function is, let's say, give a bracket x squared minus x minus 6 bracket close divided by x cubed minus 3x squared. So this is the graph. Yeah, it looks like this graph, they do not show it, the graph. But we have another software, another online versions where they will actually show. We have more graphing. So you see, this is the place like concepts becomes more important. Like concepts are important. We should have the concept. We cannot entirely trust. We cannot entirely trust this machine. Symbolab, SYM, yeah, Symbolab. Symbolab is another good, very good online website where they also draw. And this is actually heavily powerful. This is too powerful. Symbolab is too powerful. Actually, I should not show you this all these tricks that Symbolab has, because you will be like, now I know where to find this and that. So x squared, I will show you what I mean by the powerful. See, here you can write the equation actually in the like equation format. This is massively powerful. You will see. X cubed minus 3x squared, 3x squared. So you want the graph of this. We can actually go for some detail also. Okay, let's write y equals to, because Symbolab is thinking it is an expression actually, and it is an expression, but Desmos actually takes it as now you will see actually function graph. Desmos actually thinks that as equation, which is completely different. In fact, it should be like y equals to something, then it is an equation. Okay, so here is the graph, and you see the hole here. See, there is a hole. Now, since this is the last lesson of graphing, please don't misuse this. I will tell you a lot of secret. Please don't misuse it, but you can use it for your learning. See, this software will actually find out everything, or your vertical asymptote, horizontal asymptote. This website actually finds everything for your domain, everything for you. So, but please don't misuse it. But if you are curious, if you are careful, this is your kind of problem solver. You can just just for your checking, you can check everything here. So Symbolab is, that's why I said Symbolab is super powerful. It will calculate everything. So this is the graph, and this is the hole. You can see, you can see that hole, and you can see 3 comma that 5 by 9. That is the hole, because it is undefined. They actually mention it here also. At this point, it is undefined. That's why it is a hole. This is x-intercept at minus 2 comma 0. This is another Global minimum, that means this is the lowest point, that is the where the graph will go. So this is super powerful, and this app actually they have some pre-calculus section also. This website, which is quite like, oh my god, they have everything for us. All right, so I think you have seen that, and now you are confident that yeah, what you are doing is correct, and the software, highly powerful softwares also agree with us. Okay. This is another one. So let's say you have this question: fx equals to x cubed plus x squared minus 5x plus 3 divided by x squared. So if this is the question, what do you do? First of all, in the same method, we try to find out doing some simplification, and we get this simplification divided by x squared. This is the test for the asymptote. In this case, as you can see, power is more in the above. You try to solve it, then you will automatically start seeing all these steps. So we have it here, like first of all, from here to here, how it comes from that, we try to find a rational zero, and then we try to do this and that, for what value it is zero, then synthetic division. This way it comes from this line to this line. Then here it is power 1 less, here it is power 1 more. That is how we know that it will have oblique asymptote. And how do we find oblique asymptote? We do the long division, then we get this line. And then to find out the point of intersection in between the oblique asymptote and the given function of the graph, I'm just cooking rice there, so I'm thinking if the rice is burned by now. So this is what I'm looking at. Hopefully, do you know what happened? Don't take it. Don't laugh. Do you know what happened the other day? I was doing this recording and other things, since I'm the only one living here in my place. So I was making this recording, and what happened is I got so into like fun and interesting. I was talking about this and that, and all of a sudden I felt like the smell of some biscuit, and I was like, how come in my room the smell of biscuit? Today I do not have any biscuit in my room. Then I started like, okay, that's a wrong smell I'm getting. Then I started explaining this and this little more. Then all of a sudden, no, it's biscuit. Then I was like, I don't get it, because the smell from other side should not come. Then all of a sudden, oh my god, my rice is burning there. And I went there, and like the entire bottom of that container is burned. And I'm like, oh my god. So this is, and I became happy because now I know how it smells. It smells like some type of, not all of them, or some type of biscuit smell when it burns. And yeah, this is crazy. Of course, I had to cook again in that case. Anyways, that's what going on there. So how do we connect it? Let's come back. X cubed plus x squared minus 5x this divided by this. So we write this equal to the asymptote, then we do the calculation. In this case, of course, we get a point of intersection because this is a solution. This is a solution. That is the reason how we know. We get a solution. Then we continue it. You will try to draw this. We will not show the whole drawing here, so that we can you have something to do. Okay, try to draw it. These are the points that we have found so far, x-intercepts, and we got this oblique asymptote. So how do you draw? This is the point of intersection at which we know that they will intersect. And then other information, try to mix them together, find some additional points, draw it, then we will show the drawing in the class. Okay? As you know, here it will touch. This is another question. This will be in our participation. This will be in our participation quiz, lesson participation quiz. Yeah, that's all for today. Thank you all. Thank you very much. Have a good day, everyone, and see you all in the class. Bye-bye.